Hi, this is Dan. This is the Chapter 4, 5, and 6 Solutions video for Statistics, Spring 2013. Lots of probability and then some distributions and things like that, but let's get right to it. The first one is just you got a 70% chance of getting a good one, 30% that it's bad. So what's the probability of selecting an acceptable one? 70%. And then to get two in a row, so good, and we have an and situation, we multiply. So there's a 49% that you would get two in a row. And then what's probably getting five in a row? So it's good and good and good. So it's 0.7 times 0.7 five times, which is easier to write as 0.7 to the fifth. So about a 17% chance. On D, this is obviously it's a binomial. Either it's good or it's bad. But we're looking at how to get 3 out of 4. There's lots of ways to get 3 out of 4. You could do the first 3 and then not, and then 2 and then not and then 1. So this 4C3 is that part of the binomial probability formula that tells about all the different ways for this to happen. So that's actually there's 4 different ways. Then we got 3 successes or 3 good ones and 1 that's not. So there's about a 41% chance. And then this next one is what's probably that's not acceptable. It's just 30%. That's the defective ones. And then this was a little tricky for some people. What's the probability that at least 1 out of 8 randomly selected products are accepted? At least 1 out of 8. So that's 1 or 2 or 3 or 4 or 5 or 6 or 7 or 8. So instead of finding all those probabilities and adding them up, the easier way is to find the complement, which is 1 minus the opposite. And the opposite of getting all 8 good would be get none good. So the only thing that would not satisfy this is 0 acceptable. So the probability that it's not acceptable is 0.3. I want that to happen 8 times in a row, so it's 0.3 to the 8th. But then I take 1 minus this opposite scenario. So there's about a 0.99999, it's almost 100% chance that it's going to be acceptable, that you'll get at least 1 out of 8 that are good. So some people forgot to minus that, and this is almost a 0. So for this part right here. Number 2. This was I was a little lenient in the grading here. Would it be unusual to guess the first letter? So if we just count 5 vowels, there's 21. 1 out of 21 is a little bit less than 5%. So would it be unusual? Yes. If you said there's 6 vowels, that'd be 1 out of 20, which is exactly 0.05. Then you could kind of say no, because it has to, if it's it says it's unusual if it's less than or equal to. So honestly, it is equal to 5. We should still say it is rare, unusual, yes. And then some people went all the way to say, well, what about W and Y? So then you could honestly make a small argument to go beyond that. So I needed to see some rationale here to why this was going to be a no. But yes, this is unusual to guess the first letter. If it's a consonant, there's a 1 out of 20 or 1 out of 21. Is it unusual to guess a vowel? That's 1 out of 5. That's much larger than 0.05. So no, that's not unusual. On 3, the first step here would be the total of rows and columns, which I've done here. A lot of people struggled with a couple of these. I think sometimes we're thinking a little too hard possibly, but if one of the flights is randomly selected, there's 140 flights, what's that it's on time? So there's 108 out of 140. That's it. And then this one is that it's late or from Podunk. So how many from Podunk? 80. How many are late? Are late is 32. So 32 out of 140, 80 out of 140. The problem is we've counted these 17 twice. So we have to subtract that off, and that's that probability of A or B, which is on your formula sheet. So 95 out of 140. On C, what's the probability that it was on time given it was with Podunk? So how many were Podunk? 80 flights. We know it's one of those flights. And how many were on time? 63 out of 80. On D, what's the probability that it's late if it's Podunk? So that's 17 out of 80. And then what's the probability that it was from upstate given it was late? So how many were late flights? We had 32 late flights. So it's 15 out of 32. And that's it for that one. All right, number 4. 25% ride bikes. That means 75% don't. So what's probably that they don't commute by bicycle? 75%. This was a little tricky. Some people didn't realize odds is success over failure compared to success over total. So you can think of it as 25 were yes, 75 is no. So it's about a 1 out of 3 ratio of yes writing to no not. and then what are the odds that they don't commute? So 75 don't, 25 do. So it's 75 to 25, or a 3-to-1 ratio of not to commuting by bicycle to ones that do. And 5, I was lenient with this one. They said, what's the expected value for the insurance policy? And you're supposed to kind of look at this, probably, I allowed it from either the viewpoint of the insurance policy or the insurance company or the policyholder. So if you're looking at what's the value for the policy, it's probably from the company's viewpoint. So they get $120, and this is their probability that they pay out. So that's that's $90. So the average is they make $30. But if you did it the other way, I counted it wrong. If you said it was -30 for the policyholder, I accepted that as well. So probability of paying out times what happens when it pays out, and then there's the premium. On 6, this is a binomial probability like the other one, 6C4, 6, well, I went exactly 4 bullseyes, so 0.47 to the 4th, and then I went 2 non-bullseyes, which is 0.53 to the 2nd, so there's about a 21% chance that would happen. 7 is just that probability of A or B. So there's 545 men, there are 72 heavy smokers here, and the problem is we've counted these 37 twice again, so we got to minus that 37 off, and there we go. It's 0.516, or about 580 out of the 1124. On 8, I made this one extra credit. I think we had 2 or 3 people get it. This is asking what's the probability that you pass on this true false, and you got to get 6 or more. So 6 or 7 or 8 or 9 or 10. So if you run all of those binomial probabilities, you got about a 37%. Some people were aware of a cumulative distribution function. I think one person did that on their calculator and got the same. So really you're just saying this is 6 or 7 or 8 or 9 or 10 correct. So if you add all those up, really this 0.5 to the 9th times 0.5 to the 1st, all of these end up being 0.5 to the 10th, all of these. So if you factor that out, it says 0.5 to the 10th times, well, how many combinations are there to do this? How many? So it's 210, 120. So that was a tricky one. I made extra credit, 1 point. The next one was not extra credit. Pretty much what's probably getting 9 out of 10, the same binomial probability. And there it is. It's about a little less than 1% chance. Number 9, how many digits, how many numbers with 3 digits, and there's 7, so it's 7 times 7 times 7, 343. If you do not allow repeating, that means there's 7 for the first one, but only 6, and then 5, so it's 210 if repetition is not allowed. And this third one here is actually screw up. There's actually 9 digits in the Social Security, but if you honestly did it with 9 and you showed the work, I gave you credit. But it's really 10 times 10 times 10 to the 8th power, which means there's 100 million Social Security numbers if there's only 8 digits. Well, there's more Americans than that, so that wouldn't work, which is why we need 9 digits, which makes that 1 billion. So there are 1 billion Social Security numbers, and eventually we'll run out of those, or we might actually be starting to reuse a lot of those too. So anyway, so that should have been 9, but 10 to the 8th is the answer. And then 10, just look up -1.82 on your Z table. And you get 0.0349, and then just take 1 minus that because we went to the area to the right. The only error I saw on that one is some people weren't including this shaded. This is shaded. You want to include all of that. 11, you can look up -1.17, 1.17. There's the 2 p-values, and you find the difference. So the area between them is 0.758. So you get these 2 numbers from your Z table, the 0.879 and the 0.121. Number 12, normally distributed, you want the top 2%. So you got to be able to go to your Z table. And let me pull that up real quick here. Let's go to the Z table here. Let's see here, stats, formula sheets, Z table. Okay, so if I want the top 2%, I got to look in the body for the top 2%. And that's about right here, which is about 2.06 or 2.07 or 2.05, 2.06, right in there. 2.0 right in there. So I accepted either of those, 2.05 or 2.06. You got to be a little over 2 standard deviations above the mean. So if we look here, a little more than 2, 2.06 is the Z-score. We don't know the the temperature, but we know the mean and we know the standard deviation. So we do a little algebra, cross multiply by 0.62, add 98.2. So 99.5 degrees is about the top. If you have an average temperature about that or higher, you're in the top 2%. And then on 13, they want the bottom 25%. So if you look that up again on your Z table, the bottom 25% is 0.67. If I pull that up real quick, the bottom 25% is right about here. So about 0.67 right there. That's the bottom 25%, negative 0.67. And then same thing, cross multiply here by the standard deviation, add 39.9. So about a score of 35.4 would be the cutoff for the bottom 25%. And this one actually caused some problems. What's the cutoff score for the 50th percentile? Well, that's right in the middle, which is 39.9. That's a Z-score of 0. So 39.9 is the cutoff for the 50th percentile. On 14, this is the straight-up Z-score, kind of like what we did in the last exam. The Z-score is 1. Area to the right is 0.1587. What's probably it's above? Now the new stuff is what's the probably the mean for the group of teachers. Some people forgot this division sign for some reason. That's right in your formula sheet. That's actually 4 standard deviations above the mean, which means that's really, really small. Almost a 0 chance that you would get an average of 16 teachers to be above that. So, you know, an answer of almost 0 would be a really good answer. On 15, you've got you're trying to compare 2 exams. So here's the one exam average score. You're trying to figure out what the equivalent score is in the second exam. So I drew these pictures, which helps. So we calculate the Z-score. It's about 0.85 standard deviations above the average. So we go down here and say, okay, this one must also be 0.85 standard deviations above the mean. And we solve this. We don't know what the score is, but we know the mean and the standard deviation, similar to those others. Cross multiply, add 70 right here. So about 79.95 or about 80 would be equivalent score on this. A 29 in this score is about the same as an 80 on this test. On 16, this is very similar to last chapter as well. Some people didn't find the area because we went above 7.6 hours, which ends up being about 84%, and the Z-score was -1. Now, what's the average for 9 of them? Well, if we divide by the square root of 9, we get a Z-score of -3. And if you look that up, it's 0.0013. So the area to the right of that is 0.9987. Again, if I saw a mistake here, it's usually they forgot to subtract it from 1 and get the area to the right like this. And that's why drawing the picture is useful. And that's it. So I hope that video helps and get you ready for your final or for a test that's maybe coming up in the semester you're watching this.